Hey guys, homework help video here for page 247 and 248. This is for section 24.3, and again that is on page 247 to 248. I'm gonna go through most of this with you, get you going. If you're struggling, you can use this as a check, or you can use this for help if you're stuck. But this lesson was all about continuing to apply the Pythagorean theorem, which you can probably tell me by now is a squared plus b squared equals c squared for all right triangles. And remember, a and b are the smaller legs, c is always the hypotenuse, which is the longest side. So for this first page, let's take a look at the diagram, the example at the top. It says the diagram shows a diagonal drawn from point A to point B in the rectangular prism. How can you find the length of the diagonal? So that's listed as D. You can use what you know about right triangles that are related to the diagonal. The triangle on the base of the prism with the sides 6 and 8 and C. So you can see at the bottom here we have 6 by 8 by C, and it's a rectangle, so that's a right angle. Is a right triangle. The triangle that includes the diagonal from point A to B has side lengths 24. So I'm just kind of picturing with the C down there, this height up here has to be the same as the other height, so this is also 24. And we don't know the diagonal D yet. Use the Pythagorean theorem to solve for C, and then use C and the Pythagorean theorem to solve for D. So it's very similar to the example in the lesson video for this section. So that's kind of what we're breaking down for this on these first couple of problems here. Oops, sorry about that. Okay, number one. How do you know that the triangle with sides 6, 8, and C is a right triangle? So that's the very bottom triangle here. So the very bottom triangle, how do you know it's a right triangle? Well, we're given that it's a rectangular prism, and everything you know about a rectangular prism is that it's a 3D shape that has all rectangles for faces. Rectangular prisms have all rectangular sides or faces, and rectangles have right angles. And so because of that, we know that that angle is a right angle. So we have a right triangle. So then in number two, how do you know that the triangle with sides C, 24, and D is a right triangle as well? Same idea. Everything that's formed is right triangle. So we could say the 3D figure is a rectangular prism, so all the faces are rectangular. And so all the sides, like the D, is going to be perpendicular. I'm going to just copy this one. Well, we'll write it a little bit differently. But again, because it's a rectangular prism, we'll say the height lengths are perpendicular to all the bases, all the base lengths. So they form right angles, which means we have a right triangle as well there. So it says use the Pythagorean theorem to write the equations to find C and D and show your work. Okay, find the value of C and then find the value of D. So what we said there, that little triangle, that 6 by, what was it, a 6 by 8. So 6, 8, and C. This is a right angle. Oh, this is a 6, not a C. We can use the Pythagorean theorem. 6 and 8 are our two legs, so 6 squared plus 8 squared. C is the hypotenuse, so it should be equal to C squared. All right, let's do some math. 36. That's 64. Let's add those together because it says 36 plus 64, which is 100. And last step is to do this, the square root of C to get, or C squared to get C. So C is actually 10. And I believe we're talking about, oh, it doesn't have units here, so 10 units. Now that helps us with that bigger triangle, that one that goes that diagonal. So I'm going to try to redraw that. It shows the whole height, which we said was 24. It shows the C, which we now have is 10. This will make a right angle. And that dotted line on the example that goes diagonally across, that is what we're trying to find. That's the D. That's the diagonal that's listed. So, hey, guess what? We have a right triangle. We can use the Pythagorean theorem again because we have two sides and one missing. So the two sides that we have are the legs again. So 10 squared plus 24 squared. And then the hypotenuse is D because it's across the right angle. It's the biggest side. So 100 plus, I don't know, 24 squared. Check it on a calculator if you don't know. 24 times 24. 576. So if you add those together, it should be 676. And that should be equal to D squared. All right. Let's finish it off. Take the square root to get D by itself. The square root of 676 is 26. Hey, it's a perfect square, or a perfect whole number. So that means we have a Pythagorean triple. So it'd be a 10 by 24 by 26 right triangle. So that's 26 units for D. All right. So it's a two-step problem for these, most of them, because as you notice, if we're trying to find D, to make a right triangle, you needed one other side, and so we had to use Pythagorean theorem to find C. Let's do that with, I'm not going to do every one on the back. You'll notice that number 4 is very similar. I'd like you to do this on your own. It's actually, two of the numbers are even the same. The only thing that's different is the 12 versus the 24. I am going to do number 5 here with you, though. Okay. Slightly different, but using another 3D example. It says Tyler wants to ship a fishing pole that is 7 feet long. If you've ever figured that out, I've actually had to do that before. We had to send it on a plane, so we had to fit it in something. So Tyler wants to ship a fishing pole that is 7 feet long. He will use the box that is a rectangular prism with a base that is 4 by 3, so that's given here and here. And what is the shortest whole number height that will hold the fishing pole? So it's a 7 foot long fishing pole. That means if you're going to fit it in there, we want this diagonal, this dashed line here, to be at least 7 feet. So we're going to assume it's 7 feet. If it's anything bigger than 7 feet, awesome. But it can't be smaller than 7 feet. So we're going to set it at 7 feet. We're going to say that that's at least 7 feet here. So I'm picturing, again, a couple triangles. What we're trying to find ultimately is what's the shortest whole number height. So we're trying to find this ultimately. But we also, let me get rid of that for a second. We also, but the 7 with the D, the only other thing that it could form is a right triangle going across here. And we don't know that length yet, but we do know the 4 by 3 that's on the bottom. So the bottom is, I'm just going to kind of picture the 4, if I cut it in half, the 4 by 3, and we'll call that our C, the diagonal across there. So we can find that diagonal then to help us find the D. So let's do that. 4 squared plus 3 squared, or reverse, it could be 3 squared plus 4 squared, equals C squared. You might remember this is a Pythagorean triple, very common one. If you know what C is, you can write it down there with the reason that it's a Pythagorean triple. Or you can do 16 plus 9. Add them together, you get 25. And then square root of 25 is 5. So C is 25 or is 5 feet. So that means that this line right here is 5 feet, sorry. So now if I look at that bigger triangle, got the whole D that we don't know. That diagonal now is 5 feet. Or now it's the base of this triangle, and then the dashed line going across that big diagonal, which we're saying is the fishing pole, is 7 feet. It has to be 7 feet or higher. So we want to find the minimum amount, so we'll say it's 7 feet. The minimum height that this would have to be. So now when I look at that, it does form a right triangle again, so we can use the Pythagorean theorem again. But this time what we're missing, what we're trying to find is one of the legs. We have the hypotenuse, which is 7, so that's our C. This will be our A, and we're trying to find that missing part. So 5 squared plus that D squared equals the C squared, which is 7 squared. Okay, this might end up being, I'm going to warn you, it might end up being a decimal, which is fine. We'll just round it to the nearest whole number, so the shortest whole number height. So we won't want to round down, we'll have to round up if anything. So 25 plus D squared equals 7 squared is 49, minus 25. D squared equals 24. And square root of both sides, D is equal to, well, that's going to be very close to 5, right? Because the square root of 25 is 5. What was the square root of 24? We get 4.9-ish. But it does say, what's the shortest whole number height? So we'd want that height to be at least, we're going to go up to 5. So we want the height to be 5 feet as well. All right. So again, we used the Pythagorean theorem a couple times, but we ultimately wanted to find that D, which is the height of the box that we want to have. So we want a minimum of a 5 foot tall box here so that we can fit the fishing pole in there. All right, it says for number 6, the last one, write a real world problem about a rectangular prism that can be solved by using the Pythagorean theorem. Number 5 was an example of that. You have to come up with your own and then show how to solve it. Okay, so I would think about all the numbers we've used for the Pythagorean theorem and try to use the ones that will work the best, but really you can use any numbers. But make it a real world problem, make it your own. All right, so that one I'm going to have you do on your own as well. But it's all based on what we've been doing. I hope that was helpful for lesson 24.3. If you continue to have questions, make sure you ask. And otherwise, that's it. Have a great rest of your day, everyone.